Welcome to OTO, the Out of the Office Investigation into Personal Health, Understanding and Actualization. This time we're discussing reality, quantum physics, string theory, multiverse, and higher dimensions.
Welcome, everyone. So today, Mason and I are going to get into the very fabric of existence. We're starting with the biggest, most mind-bending questions you can imagine from modern physics, and we're going to trace them all the way back to one single crucial point. What could understanding the nature of reality possibly mean for our own health and our potential?
Exactly. We're going to look at how physicists believe the universe is literally woven together, and then, we'll investigate how we can use that very same understanding to maybe reweave the fabric of our own well-being. Okay, so let's just start with the most fundamental question there is. It's one that really challenges our day-to-day experience. It almost sounds crazy to ask, but it's where any real investigation has to begin.
Right. Is the world you see truly there? Are your senses giving you the full, unfiltered picture of what's actually out there, or are they just showing you a convenient, edited version that helps you get by?
And that question, it leads us straight to this critical distinction. On one side, you've got objective reality. That's the stuff that physicists are trying to figure out. It's what exists whether we're here to see it or not. The moon, the laws of gravity, all those tiny fundamental particles. It's the territory itself.
But what we actually experience every single moment of our lives is perceived reality. And this is not a clear window onto that territory. It's more like a map that our brain draws of it. Just think about the color red for a second. In objective reality, red doesn't exist. There's just light of a specific wavelength. Your eye catches it, your brain processes it, and it creates the internal experience you call red. Same with the taste of chocolate or the sound of music. They are all amazing constructions. It's like our brain's user interface with the world.
And, as neuroscientists will tell you, this interface was not designed for perfect accuracy. It was designed for survival. It's a super useful interpretation for sure, but it is not a literal one-to-one picture of the world.
So, keeping that in mind, here's the path we're going to take on our little investigation today. We'll start by digging a little deeper into that gap between our senses and what's true. Then we're going to journey right into the heart of modern physics and face its great divide. And it is a massive conflict between our two most successful theories. From there, we'll get into the wild, super ambitious theories trying to solve that crisis, things like string theory and loop quantum gravity. Then we'll zoom out even further and consider worlds beyond our own, these incredible concepts of multiverses and simulated realities. And finally, we're going to bring it all the way back home and ask, what is the blueprint for health that we can actually draw from all this cosmic strangeness? All right, section 1. Look, before we can even begin to talk about the universe, we have to be really honest about the tools we're using to look at it in the first place, which are our own minds and senses. Because if those tools are, distorting the picture, we really need to understand how. And this slide, wow, it just brilliantly shows that distortion in action. So when you hear two pure musical tones played together, let's say a C and a G, your brain perceives a chord, but you can still pick out the individual notes, right? You hear both the C and the G. Your auditory system is giving you a pretty accurate report of the data it's getting.
But our eyes, our visual system, it plays by a totally different set of rules. If you take two pure frequencies of light, spectral red and spectral green, and you mix them, you don't see a chord of red and green, no way. Your brain just creates an entirely new, single color, yellow. It's almost like if playing a C and a G made you hear a totally different note, like an E. The original information is just gone, and it's replaced by this new construction.
And that tells us something really profound. Evolution didn't care about showing us objective truth. It cared about keeping us alive. Seeing a yellow fruit against green leaves was just a useful shortcut that helped us find food. So our perception is a survival tool, not a truth machine. And that just fundamentally challenges how much we can really trust our own raw experience.
So if our personal reality is a construction, what about the fundamental reality that physics is trying to describe? Well, this is where things get even weirder. We've now arrived at the core crisis of modern physics. Our entire understanding of the universe is built on two incredible theories that are, fundamentally incompatible with each other. On one side of this huge divide, you have Einstein's masterpiece, general relativity. This is the theory of the really, really big things. It describes gravity not as some mysterious force, but as the elegant curvature of the smooth, continuous fabric called space-time. Planets, stars, galaxies, they all just move along the curves in that fabric. It's a beautiful, deterministic map of the cosmos. And then on the other side, you have quantum mechanics, which is the rule book for the very, very small. And its rules are probabilistic and just bizarre. It says a particle, like an electron, isn't in just one place, but it exists as this cloud of probabilities, a superposition of being in many places all at once.
And this is exactly where the two theories have a head-on collision. I mean, if an electron has mass, general relativity says it must curve spacetime. But if quantum mechanics says the electron is in many places at once, then where is the curvature? Does spacetime itself curve in a bunch of different ways at the same time? General relativity has no idea. The math just completely breaks.
Yeah, and this weirdness is just baked right into the theory. You have the uncertainty principle, which puts a fundamental limit on what we can even know about a particle. Then there's wave-particle duality, which tells us that the building blocks of reality can be both a localized little point and a spread-out wave at the same time.
And then there's entanglement, which Einstein famously called spooky action at a distance. You can link two particles so that measuring one instantly influences the other, even if they're on opposite sides of the universe. These aren't just little quirks, they are the proven laws of the microworld, and they just can't seem to coexist with the smooth, predictable laws of the macroworld.
This quote from the physicist Arvin Ash just nails the whole problem. This isn't just some abstract puzzle for scientists in a lab. We live in one single unified universe. The atoms in your own body are following the bizarre laws of quantum mechanics, but the gravity holding you to the Earth is following the elegant laws of general relativity.
Those rules have to connect somewhere. They have to merge. And this deep contradiction is the real driving force behind the entire quest for a so-called theory of everything, a single set of laws that can describe reality at absolutely every scale.
You're listening to OTO with research by author Paul Bullo. So how in the world do we solve this crisis? How do we possibly bridge this great divide? Well, this brings us to two of the most ambitious and frankly mind-bending projects in all of science. These are the leading attempts to stitch the quantum world and the cosmic world together into one single coherent tapestry. Okay, so the more famous of the two is string theory. For decades now, our best model of particle physics has treated fundamental particles like electrons as these little zero-dimensional points. String theory makes what sounds like a simple change. What if they're not points? What if they're tiny, one-dimensional vibrating loops of energy?
And the result of that one simple change is just astonishing. Think about it. Just like a guitar string can vibrate at different frequencies to produce different musical notes, string theory proposes that these fundamental strings, vibrating in different patterns, actually produce all the different particles we see. So an electron is just a string vibrating one way. A photon is the exact same kind of string, just vibrating another way. It suggests the entire universe is this grand cosmic symphony played on these tiny, tiny strings.
That is an incredibly elegant idea, Mason, but string theory's main competitor, loop quantum gravity, says it doesn't quite go far enough. String theory still assumes that these strings are vibrating on a pre-existing background, on a stage called spacetime.
That's right, and that's the very problem loop quantum gravity tries to solve. It says the background stage is the main character. It argues that if you could zoom into the smallest possible scale, the Planck scale, you'd find that space and time are not smooth and continuous. They're actually made of discrete, indivisible pixels of space-time. So in this view, gravity isn't a force moving through space. It's a property of the network of these pixels themselves. It's really an attempt to digitize reality.
Okay, let's circle back to string theory for a minute, because it comes with this really bizarre requirement. For the math to work out, it needs more dimensions than the 3 of space and 1 of time that we all experience. And this analogy is the classic way to get your head around how that could even be possible.
Right. Imagine you're looking at a garden hose from miles away. It just looks like a simple one-dimensional line. But if you get right up close, you realize there's a second dimension, the circumference. An ant on that hose can walk along its length, sure, but it can also walk around that tiny, curled-up circular dimension. String theory suggests that extraspatial dimensions could be just like that, curled up to an impossibly small size, existing at every single point in space, but completely invisible to us.
And this isn't just some fun, speculative idea. It's a mathematical necessity. The equations of string theory only become consistent. They only avoid spitting out nonsensical infinities in a universe with 10 space-time dimensions. So that's 9 dimensions of space plus 1 of time. It's an incredible leap, for sure, but what's so fascinating is that a lot of physicists don't see this as a bug, but as a feature. The complex geometry of how these 6 extra dimensions can be curled up is what gives the strings the room they need to vibrate in all the different ways necessary to create the whole zoo of particles and forces we see in our universe. In a very real sense, the shape of those tiny hidden dimensions actually determines the laws of physics.
And that very idea that the shape of hidden dimensions determines the laws of physics is the perfect gateway to the most speculative and expansive implications of these theories. We're now moving beyond just our universe and into ideas that really challenge the uniqueness of our entire existence.
So if the laws of physics depend on the geometry of those extra dimensions, well, the next obvious question is there only one way for them to be shaped? The math behind M-theory, which is a more advanced version of string theory, suggests the answer is a big, loud no. There isn't just one stable shape, but this vast landscape of possibilities.
And the number of these possible stable configurations is estimated to be around 10 to the power of 500. That is a 1 followed by 500 zeros. It's a number so huge it's basically infinite. Each one of those configurations would spawn a universe with its own unique set of physical laws. And this is the scientific origin of the multiverse, a huge cosmic collection of bubble universes, each with its own physics, all just emerging from the fundamental mathematics of string theory.
Okay, so if an infinite multiverse isn't strange enough for you, let's explore another possibility, the simulation hypothesis. The philosopher Nick Bostrom proposed this really compelling logical argument called the simulation trilemma. It doesn't claim we are in a simulation, but it argues that one of these three propositions is almost certainly true.
Let me just walk through it real quick. Proposition 1, civilizations like ours almost always go extinct before they can develop the technology to create hyper-realistic ancestor simulations. Okay. Proposition 2, advanced civilizations that do survive simply lose all interest in creating these simulations. But Proposition 3, if those first two are false, meaning civilizations survive and they stay interested, then they are going to inevitably create a ridiculous number of these simulations. In that scenario, the number of simulated realities would just vastly outnumber the single base reality. And by pure statistics, we would almost certainly be living in one of the simulations.
And that, of course, leads to the ultimate question. If we're characters in a program, who wrote the code? Neil deGrasse Tyson has this funny image of our entire universe just being the science fair project of some snot-nosed alien kid.
It's a fun thought, but he also raises the really crucial counterpoint. Even if it's true, so what? Does it actually change anything about our lived experience? I mean, we still have to get up in the morning, we still experience love and pain and joy. If the simulation is perfect, then our reality is functionally indistinguishable from a base reality. Maybe the question doesn't even matter.
You're listening to Odo Sum with research by author Paul Bulow. So, Bobby, after this entire journey, through a reality that is a construct of our minds, a universe governed by two conflicting sets of rules, a cosmos that's potentially filled with hidden dimensions, multiple universes, and maybe even running on some cosmic computer, we finally arrive at the most important question for us here at OTO. How can understanding this vast, strange reality possibly affect our mental and physical health?
I think it has a profound effect, Mason, because it fundamentally changes our relationship with ourselves and with our circumstances. Quantum mechanics tells us that, at a really basic level, reality is a set of probabilities until it's observed. And that is such a powerful metaphor. It means we can shift from being these passive recipients of our life story to being active observers whose focus and intention actually help shape our reality. Realizing our perception is a construct gives us the power to question our limiting beliefs. And this awareness, it aligns our bodies to a deeper understanding of truth and perception, which fosters a healthy environment for both mental and physical success. It's really about moving from a rigid, deterministic mindset to a participatory one. That's a really powerful shift. So, what are the key elements we can focus on to put this into practice? Looking at this list here, this new perspective really reframes everything. If reality is a deeply interconnected web, like concepts like quantum entanglement suggest, then these health choices aren't just isolated events. This suggests our body's health is deeply connected to our diet, our actions, nutrition, sunlight, fresh air, our personal energy, and especially that clarity routine of aligning our actions, our words, and our thoughts. These aren't just inputs into a biological machine. They're information that gets entangled with the entire complex system of our well-being.
Exactly. Let's make that even more concrete. We know that this integrated understanding, this way of thinking, aligns healthy daily choices for diet, behaviors, and medical care, and is absolutely critical to our physical and mental health. For instance, take recovery from a condition like hypertension. A purely classical mechanical view says, okay, the machine is broken, take this pill to fix this one part. That can feel really disempowering and stressful. But a more holistic view, one inspired by all this physics, recognizes that the stress of believing you are a broken machine itself contributes to high blood pressure. Understanding that you are an integrated system where your thoughts, your food, your environment are all entangled with your physiology makes choices about meditation or diet so much more meaningful, because you see them as fundamentally altering the entire system, not just treating a single symptom. So this brings us to our final question. Can this awareness of reality truly improve our mental health, our relationships, and even support peak physical performance? I absolutely believe the answer is yes. Contemplating the vastness of reality and the limits of our own perception fosters humility, curiosity, and a sense of awe. It shifts us from anxiously trying to control a rigid world to participating gracefully in a dynamic, mysterious one. And this perspective can be directly linked to an overall healthy outlook and a more peaceful life.
And that brings us to this final, just incredibly empowering quote from Neil deGrasse Tyson. This is the ultimate takeaway. If reality is this strange, this malleable, this vast, then our purpose isn't to find some pre-written meaning out there in the cosmos. It's to create meaning. We have the power to make meaning in our lives. So the ultimate message from the frontiers of physics isn't one of cosmic irrelevance. It's one of profound personal empowerment. We are the meaning makers, invited to build our own reality, one conscious, healthy, and aligned choice at a time.